Sir, a few months ago, we read in a newspaper that you had discovered a compound which basically increases the carbon dioxide capture in the atmosphere. So, could you please elaborate more on it? We are eager to know.
Thank you, Asmi. So, just to start with, we have to make it clear to you that it's not just my work, and this compound was not discovered by us. It was discovered in the University of Calgary, but we had some contribution towards it. The entire work started in 2010, where we made this compound called metal organic framework, and it is a big class of compounds. Many people work on it, but what we made was a very specific composition, where it was a zinc aminotriazole oxalate, and so this was a solid material with which you can capture the CO2 because the amine groups can interact with the CO2 better. So that was the concept of it. And what we have done in that work is that we also show using X-ray crystallography that the CO2 can be located within the pores of this molecular sponge, the MOF, and we showed that it has interactions with the amine groups which are lining the pores within this material. So that was something that people had envisaged before that, but there are no direct evidence for it. So we were the first ones to provide a direct evidence through crystallography, and that made it quite attractive to many. But following that, in Calgary, it was a George Shimizu, Jane Bin Lin, and a team of people. They took over the idea and the kind of composition what we had developed as being very effective, and then they expanded it by making a slightly different composition but with a very similar structure, where it was a zinc triazole oxalate. So I told you the first ones we made were zinc aminotriazole oxalate, whereas these were zinc triazole oxalate. And triazoles being a basic group, still it is capable of interacting with CO2. So you really don't need the amine group so critically. And this composition, or MOF, they named it as CAF20, CAF standing for Calgary Frameworks. And it does a fantastic job of capturing about 4 millimoles per gram of CO2, okay, which is quite a good number. But there are compounds which can do bigger than that, but then you also have to look at what is called a selectivity for CO2 over other gases. And that was pretty good for this CAF20. And so people had always seen MOFs as being a good sorbent for CO2, but more of an academic interest was only available because there are no demonstrations at the industrial scale. Whereas in this CAF20, what Professor George and his team had done is that they had managed to scale it up to kilograms in the lab and convince industrial people to take interest into it. And they pursued it very rigorously and got a Canadian company, Swante, to kind of develop it into a membrane where you produce ton scales of this MOF, and that was done in collaboration with BASF Germany. And then they took the ton scales and then they engineered it at Swante into a gas capturing membrane. And this membrane can capture 1 ton of CO2 per day. Okay, and these materials are completely recyclable in the sense like the adsorption, desorption based on which it operates is very reversible, and the same material can do millions of cycles of adsorption, desorption without losing its capacity or selectivity, and that makes them very interesting. And in this paper, they have developed all this ton scale capacity. They have demonstrated it. They have shown that it has a huge affinity towards CO2 and very little towards nitrogen. And one of the important things they have shown is that despite being a less polar molecule than water, the CO2 still in this material is able to have so much affinity that it adsorbs on the material much better than what even water does. And that is very technically demonstrated with very quantified values. So that makes it very, very important, because that is something that has been a huge challenge for many of the adsorbent materials which are being looked at for CO2 adsorption in the presence of humidity. Okay, so that's That's what this entire paper is about. Thank you.